Welcome, everyone. Thank you for attending the Interchain session today. I am Michelle from Lambda256, and I'm in charge of MUB staff for the company. Lambda256 is a subsidiary of Dunamu and also provides blockchain service platform called Universe for the Web3 developers. Today, I'm very excited to discuss the future of Interchain with one of the great speakers in the blockchain industry. So, yeah, now we invite Bryan Pellegrino, CEO of the Leiyerzero Labs. So, welcome, Bryan.
Thank you so much.
Yeah. So, would you please introduce yourself? Yeah, including who you are and then what your background is, so on.
Sure. So Bryan, one of 3 founders and CEO of LayerZero Labs, so creator of LayerZero and Stargate. Background is very eclectic, so I'm sure some of you guys may have heard this before, but I grew up in a very small village, about 900 people. Got a computer when I was young and just like fell in love with it. Went to school for computer science. But dropped out after 3 years to play poker professionally.
Oh, yeah.
So I played poker for 8 years, traveled to 80 countries during the time, and so played all over the world at the highest stakes you could possibly play. But then poker got banned in the US, and so I was out of a job and had to figure out what the heck to do with my life. So started a company.
Wow. Yeah.
Sold that company. Wrote some machine learning models that I sold to some of the professional baseball teams. Started another company in the Valley that got acquired. And then I did academic research for a year and published with Facebook. And then now I'm here doing this. But I've been in crypto since 2013, so almost 10 years now, which feels like forever.
Yeah, so wow, it is very interesting that you are a professional poker game player before, and then so I guess that you earned a lot of money at that time, right?
I mean, it was my living for 8 years, so yeah.
Oh yeah, so okay, so yeah. Thank you for your introduction, and now shall we commence our discussion with my initial questions?
Sure.
Yep. Yeah, so first of all, so we can see so many layer 1 protocols in the market, but the fragmentation among layer 1 is one of the difficult problems currently we having now. So, but as we all know that, so the interchain technology, which can provide interoperability among the layer 1 protocol, so is one. So I think that the LayerZero is one of LayerZero is very important role in the market. But I think that LayerZero technology is still evolving now. So I want to know that. So what is your challenge you guys have encountered so now?
Yeah, so I think we think about layer 1s a little bit differently than a lot of people. So most people, you had this really big proliferation. So a lot of layer 1s all spread out, but a lot of them kind of did the same thing, right? It was like Ethereum forks that did a little bit this way or a little bit that way. And most of that, over the long run, will get washed out as technology scales better and Ethereum itself can handle more load. So I think kind of the most interesting layer 1s are these really strong orthogonal trade-offs. So Solana, which is just like fundamentally very, very different than Ethereum and is built for totally different things. And even Polygon and many of these others, and then you have the layer 2s. And so I think when you have those trade-offs, they're really just built for different use cases. And you need ways to have this layer of communication between them. You need ways to basically be able to embrace kind of the best of both. And that comes out in a lot of ways. So, when we used to build web applications 20 years ago, you would write some code and you'd put it on a computer and it would just sit at your house or in a data center if you were lucky. But today, when we write web applications, you're using microservices for everything, things that are hyper-optimized for databases, for compute, for all of these different use cases. And I see chains a lot like that, where once you have this layer of communication, this connectivity between them, you can really start to leverage the trade-offs. You could do something like you'll never be able to store everything you want to store on Ethereum, but you could have all of your storage on Arweave, and you could take that and bundle it up into a really complex computation on Solana, and then roll the result back to Ethereum, right? The possibilities of sort of different ways that you can architect applications as that moves forward really gets opened up a lot once you have this messaging highway.
Yeah, I think that maybe in the early stage of internet, I think that in the future, every chains can be connected because of the interchain technology. So now, I would like to listen to the detailed information of your company, including the strategy and vision and solution.
Yeah, so LayerZero is, a lot of people originally approached all of this as bridging, pure value transfer. So I just want to send some money across a chain. And LayerZero is pure generic messaging. So it's not a bridge, it's not a DEX, it's not any of those things. Those are things that get built on top of LayerZero. So Stargate is a bridge that was built on top of LayerZero. But kind of the biggest thing about LayerZero is really creating this base primitive that's kind of, even back before, you can draw from early internet, definitely, there were just these clusters of computers that every university had. And then eventually there were standards that were made so that these clusters could communicate. And this is what became the beginning of the internet, right? And so you need these methodologies, these primitives, in order for communication to happen. So LayerZero was meant to solve that layer. And this can be anything. It can be sending money, it can be minting NFTs across any chains, it can be lending protocols where you collateralize on one chain and borrow on another. The goal for LayerZero was to be extensive enough to do all of that. But sort of how you get there is very important, because there's a lot of solutions who sort of claim to do something similar. But the way that they do it is and this is, we've seen countless bridge hacks at this point, right? I think, we're up in the many billions of dollars of bridges that have been hacked. So I think it's very, very important to talk about how, right? To get back to the fundamentals of what actually makes a protocol versus service that you're opting into. And so, I think we're going to talk more about security in a little bit. So I'm happy to dive into it more then, because there's so much more that can have in that conversation. But I think the biggest vision of LayerZero is create this pure generic messaging layer that gives applications both the ability to abstract away complexity for the end user, to build a consumer experience that would be used by, let's say, the 95% of people, right? Something when you think about PayPal or Revolut or any of the sort of large consumer fintech apps and what those experiences look like. Long-term, we just need, developers need the ability to offer that. So things like gas abstraction and all of these other things. But more than that, the ability to lay the foundation that is, rooted in security, and to do this in a way that doesn't expose everything on top to kind of the same surface of risk.
So thank you, Bryan. So I appreciate your detailed introduction about your company, but I still have a basic question regarding the concept between bridging and the low-level communication. So can you explain more about the between bridging and the low-level communication?
Yeah. So most bridges, again, were just frameworks to send money across. And most of them did this with wrapped assets. So, they envisioned a user would have a bag of money on one chain, and they would kind of want to walk across a bridge and make it over to the other chain with their money. So the way that most did this is you lock up some assets in a contract here, and you mint some synthetic asset over there. So wrapped assets is typically how we talk about this. And so everybody is very focused just on value transfer. But generic messaging, value transfer, is just a form of messaging. At its core, what you're doing when you're transferring, it doesn't matter if you're using wrapped BTC or if you're using any other bridge, you're doing some event in a contract here and some event in a contract there. And that is the generic messaging piece. And what actually is accomplished there can be anything. This can be you're playing a game and you kill a boss, and then all of a sudden you're minted a new item over on this chain, or your profile picture is updated with a crown. This can be the ability to move an NFT, to buy something across chains. It can be the ability for DeFi protocols to, again, collateralize here, borrow over there, yield aggregators, all of this. It's really anything can be done through this core primitive. Just like when, look at what a packet on the internet is. It's a very dumb thing. There's just two computers, and you're sending some payload, some little bit of information between these two computers. But what you can build off of that very simple packet is everything that we have today. Streaming video and Netflix and Zoom and all of these things that we use in everyday life all come from these core primitives. And so I think it's very important to get that right. And then what you can build on top of that is basically limitless.
Okay, so I understand very well now. And I have another question, and I also wanted to figure out what's the practical advantage of your company's approach in terms of the basic communication level. Yep.
Yeah, so I mean, what's the practical advantage? I would say when we were building it, the things that mattered the most to us were security first and foremost. If you're going to build something that is rife with broad systemic risk, then it just doesn't matter, right? It doesn't matter if you make it 3 months or 6 months or 1 year. Eventually, you're going to get hacked, and everything you've built on top is basically ruined. And so you have to start with that baseline where security is kind of most important. And then after that, there's really optionality to the developer. So developers should have some modularity of control over their own security, and then also should have the ability to take some efforts on themselves in a way that's easy to abstract away pain from the user. So if you've ever used Stargate, one of the very nice things about it is that even if you're doing really complex things on top, so sushi swap built on top, and you're basically doing a swap, a bridge, and another swap, right? It doesn't matter what you're doing. All of this gets compressed to one single transaction, and the user only needs to think about source gas. So if you're going from Polygon to Avalanche, you don't need to have both Matic and AVAX, right? You just have Matic in your wallet, you sign one transaction, and the whole flow gets executed. And so things like that allow developers to build better experiences. Now you can think about a wallet where the user only has one asset, only has one chain, and yet can interact with DeFi protocols across all chains, right? So they can have order routing to get back execution. You can monitor 20 farms across 8 different chains, and the user doesn't ever need to know the underlying chain, the underlying gas asset. They don't need to know anything, right? They could have just USDC in their wallet and have the ability to move around seamlessly across those. And so I think that's one of the big things is the ability for developers above to build an experience that is more like the consumer experiences we know today.
So as you talk to us, so I think that security doesn't matter in terms of interchain technology, but I think that there is always a trade-off or a compromise between security and then performance. So I want to ask you, so how can the interchain technology solve this problem or these issues?
Okay, so I'm gonna have to get a little bit more technical here. So it comes down really, the way that we've approached this is that at its core, a protocol must be immutable. If me, the protocol owner, has the ability to change the security properties of the applications above, then you're just opting into a service. You're subscribing to some messaging service, but it's not a protocol. A protocol must give you a set of defined, when I send a packet on the internet or I'm doing something, there isn't a world where I worry that TCP/IP is going to change the properties and route my packet somewhere else or do something bad, right? You need these defined standards that cannot change. And so that is the first and foremost with LayerZero is it must be immutable at the contract level. So the endpoints are totally immutable. And then we publish validation libraries on top. And these validation libraries are how messages get validated. and they can get upgraded. So those also, each individually, are totally immutable, but new ones can be published. And so maybe we publish a new library that's 20% more gas efficient, or that uses zero knowledge proofs to batch validate votes for governance rather than streaming them ad hoc, or any of these different systems on top of this. The important thing is that if you want ease, so when you're talking about performance, most developers don't want to care that when Ethereum sunsets Merkle-Patricia trees and introduces Verkle trees, everything breaks if you're using a Merkle validation library, because Merkle proofs are no longer generated, right? They don't want to think about that. They don't want their applications to break. So you can be on defaults, which will auto-migrate you to the newest versions of libraries. But if you care, if you're the largest applications in the world, the Uniswaps, the Aaves, the Curves, right? Now you have the ability to point to very specific libraries, and it is impossible. It doesn't matter if all of LayerZero Labs disappears off the face of the earth today, LayerZero, the protocol, will still work forever. It will always run. There's nothing we can do to shut it down. It doesn't matter if we were 100% malicious and our only goal was to be malicious. We cannot affect negative things. We can never change the security properties of those applications. And so for us, that is the most important thing. Give developers who don't care the ability to basically be on easy mode, right? To be on defaults, on something that gives them the experience that maintains ease. But you must give the developers who care the lever to control that element of security. And I think that is really the fundamental difference.
Okay, so yeah, all right. And then actually, I have another question about security. And then I heard that LayerZero Wraps does not use a synthetic asset or wrapped asset. So I'm curious about why you guys do not use the synthetic asset or wrapped asset.
Okay, so LayerZero, to be clear, technically, you could build a wrapped asset bridge on top of LayerZero. LayerZero is a messaging protocol. A wrapped asset is just a contract that says lock some asset here and mint an IOU over there. But the problem with this is most users, when they use some protocol, some project, they're bearing some risk. When you do a swap on Uniswap, you're bearing the risk that Uniswap's contracts are correct. But when you're done, you never think about it again. You just go on with your day and you have your result on the other end. And the problem with bridges that are wrapped asset bridges now is you lock something here, you mint a synthetic over there, and usually that would be done. Your transaction would be done. But now this IOU, this wrapped asset that you have, is really, it's not a real asset, it's an IOU for the assets that are in the contract back on the base chain. What that means is you carry risk in that asset forever, as long as it exists. So if this contract gets hacked, your IOU is worth nothing. If this contract, the destination contract, gets hacked, your IOU is worth nothing. If the validation layer fails, your IOU is worth nothing. So the user carries that risk forever in the asset itself. So when we made Stargate, which is a bridge on top of LayerZero, one of the first things we said is 100% native assets. And what that means is, let's say you're bridging between Ethereum and, we'll say Avalanche. There's native USDC issued from Circle on both chains, right? So now LPs put up, $100 million on each chain, and a user can add here and subtract there. And they add real USDC on Ethereum, and they take real USDC on Avalanche. And what that means is the risk has shifted now that the LPs, the people who are providing the money, they're staking the protocol, they bear the risk of the protocol, right? They bear something being wrong in the contracts, they bear a hack, they bear that, but the user, the end user, is totally absolved of that risk now. So the end user puts in native USDC, gets out native USDC, and they just go on with their day, just like they do with any other protocol. They no longer have this carried risk in perpetuity as long as they own the asset. And moving towards that model was really one of the biggest reasons, because when you're talking about systemic risk, there were tens of billions of dollars of wrapped assets that, and again, because we keep seeing these things get hacked, that have just near unlimited exposure. And it's the users with the assets on the other end who carry that exposure, and it just shouldn't be structured like that.
All right, so yeah, to reduce the risk of the wrapped assets, so you guys do not use the wrapped assets. So I understand very well. And then, so let's move on to another topic. So now I would like to discuss gas fee issues with you. So I think that for the mass adoption of blockchain services, we needed to find a way to reduce the gas fee issues. So from user perspective, so a user needs to transfer one asset from channel A to the several chains. Yeah, the users need to have lots of tokens. So I'm wondering that in terms of interchain technology, so how the interchain technology can solve the gas fee issues or reduce the gas fee issues?
So when you do a message across chains, you still need to write state to both chains. So I need to write some transaction on Polygon and some transaction on Solana. So you're not going to avoid paying those fees because you still need to actually interact with the chains themselves, and block space costs some money, right? Ethereum block space is more expensive than Solana block space. But what LayerZero Labs does is solve for the problem that you're describing, is that as a user, if you live on Solana and you want to buy something on OpenSea Ethereum, like, you don't want to have both Sol and ETH in your wallet. You don't want to have to maintain the gas assets of all these other chains. So it does allow for that to be abstracted away. It does allow you to only have Sol, to stay in Sol and be able to interact out to all these other chains without needing to have all of those, have exposure to all of them, track 8 different wallets. So that side is very nice.
Wow, that's very convenient for users' perspective. Yep. So all right, so now, I have another question regarding sectors or industries which interchain technology has been applied to. So yeah, I think that the interchain technology has developed in especially DeFi sectors. But I think that there will be another sectors which the interchain technology can be applied to. So I want to ask you, so which sectors could be activated if the interchain technology has been applied to?
Yeah, so I mean, at its core, we're a messaging layer between all of the chains, right? So what that unlocks has been surprising. When we started, we were very focused on DeFi only, right? So trading on DEXs, lending protocols, yield aggregators, all of DeFi. Since we launched, we've had about 50% of our inbound interest has been gaming and NFTs. So a huge amount of interest from gaming and NFTs, and then also traditional finance, from the biggest banks in the world to consumer fintech to all of these things. And so I think all of these get touched by this system. Basically anything that touches a blockchain is applicable.
So yeah, I totally agree with your idea. So personally, I'm a person who think about the new NFT project. So personally, I would like to build a cross-chain NFT marketplace using your solutions.
Please do.
Yeah. So yeah, now I have another question about the position of the LayerZero compared to the Layer 2. Because the Ethereum merge has just updated, so in the near future, so which one between LayerZero and the Layer 2 has the more crucial position in the market? So what is your opinion about that?
So Layer 2 is like, a lot of things are moving these days. You see this with Avalanche subnets, Polygon supernets, Layer 2s, Arbitrum splitting into Nitro and Nova. Application-specific blockchains are becoming very, very popular. Whether this is a game having its own chain, or whether this is something like Arbitrum splitting into a DeFi chain and a gaming chain, there are different trade-offs in how you want these architectures to exist. For us, we've tried to take in the stance that we don't really care whether the world is 1,000 Layer 1s or just Ethereum as a settlement layer and 1,000 Layer 2s. It doesn't matter to us, because even between those Layer 2s, you still need horizontal composability. So if you're on Arbitrum and you're playing a game on Nova and you want to now go over to Nitro and do some DeFi thing, or vice versa, say you sold something on Nitro and you want to take your $100 and go spend it on Nova, nobody wants to wait 7 days to go back to Ethereum and then go back out, right? Like that's just like not a tenable experience of like wait 1 week to do things. So you need this layer of horizontal composability between all these L2s rather. So you need to be able to go out and go to one and then move between them. And that's what we unlock, is both to and from, but also horizontally between them.
Okay, yeah. So I think that the LayerZero has the positive future. Yeah, I think so. Yeah. And then so I have a last question. So currently I heard that you guys gained $135 million in a crowdfunding round. So I want to ask you your ultimate goal of your company in 5 or 10 years later.
My ultimate goal in 5 to 10 years is that almost nobody has ever heard of LayerZero, and you guys don't ever think about it again, right? In the way that when you use the internet today, you don't think about the underlying layer. Nobody thinks about the OSI model and the stack below. You might, if you're a CS student taking a networking class in college, but ultimately you want to be the underlying plumbing that lies below and makes all of this stuff work without needing to be direct or even thought about, right? So the point is to be ubiquitous and in the background.
So you mean that so you are making the standard of Interchain in the blockchain industry, right?
Yeah.
Yeah, all right. So now we are open to some questions from the audiences. So is there any questions from the audiences? Yeah, the first question from the audience is like that. Currently, Stargate is supporting EVM chains. So are you planning on adding non-EVM network?
Yeah, so I want to separate LayerZero and Stargate again. LayerZero will very soon, right now it's on about 11 EVM chains with about 8 more testnets, so 19-ish. We'll be live on Aptos from day one and canonical there in many of the projects. We'll be on Solana shortly, and we'll be on Sui shortly. So 3 non-EVM chains. Stargate needs to be a little bit more particular about where it goes, because 1, there needs to be native asset support there, and 2, you need to pool liquidity on the chain. So each new chain adds some element of like needing to aggregate liquidity there. We will certainly be on Solana, so without a doubt we will be going to Solana. There's native USDC there. There's a huge amount of benefit of flow going into and out of that ecosystem. But every other chain, I would say, is case-by-case basis. Obviously, all of this is sort of like at the technology layer, it's possible, it's happening. And then the DAO just decides sort of what that looks like, what gets allocated to each chain, how much, if any, emissions go there. There are a lot of chains, probably more than I can count right now, that want Stargate to go to them. But it's just a question of getting it up there and then who puts up the liquidity. If the chain themselves is going to provide liquidity, easy, right? Stargate should deploy to all of those chains who will do that. But if Stargate needs to put up its own liquidity, then it becomes a little bit more of a nuanced conversation into does it actually make sense? The amount that Stargate will pay to move its own protocol and liquidity there or support emissions, is that worth it to the fees kind of going in and out of the ecosystem? But to answer the question kind of more briefly, yes, 100% will be going to non-EVM networks.
All right, so next question is, yeah, such like that. So I think Stargate concentrating on the stablecoin pool is pretty smart, but how does Stargate make sure it is secure if it does not have a validate?
Yeah, so, okay. Stargate is built on top of LayerZero, right? So it inherits LayerZero's security properties. So, you know, I think of basically every existing system, LayerZero has had more TVL, more volume, right? Billions in TVL, billions of dollars of transactional volume. There's going to be, you know, a couple projects building right now that are many billions of TVL again, and market cap sort of building on top. So in terms of like what that has secured, you LayerZero has done 20+ audits, has spent almost $4 million this year alone on audits, invented things like pre-crime, which I'm happy to sort of dive more into, but like really, really on the forefront of security. So Stargate specifically inherits all of that. So like pre-crime is a great example where so bridges, right? It's crazy that in an atomic setting, so when you're just on Ethereum, right? If you get hacked, it sucks. Your contract is bad and all your money's gone. There's really nothing you can do in an atomic setting because it happens like that. But when you have a non-atomic setting, when you're going between chains, there's a little bit of latency, right? So you have to write some transaction here and then move the message and write a transaction over here. And that little bit of latency introduces like some really unique opportunities. So one thing that we did with that is this concept of pre-crime. And so what Stargate does, when you look at other bridge hacks, Nomad hack took like hours. Everybody watched the hack happen. Slowly, 190 million was being drained. Everybody knew it was bad. Everybody knew the messages was going through bad, but you just had to sit and watch it, right? Axie Ronin hack for $650 million. Like very clearly to anybody standing on the outside says, if you're giving $650 million over here and you don't have anything over there, like that's not a good transaction, right? But it's just crazy that there's nothing that has been like checking that throughout. So what pre-crime does is says, take this transaction that's going to happen, fork every chain locally, and run that state transition locally, and then check the resulting state against a list of invariants that the protocol defines. So for Stargate, it's very clear, right? The invariant is solvency. If I'm giving out 20 million over here, did I get 20 million over there? Is the system still solvent? And if it's not solvent, then it will not make that message, right? That transfer will not go through and it won't happen. So there are all of these other things on top of Stargate that go into security that aren't really widely talked about now, but we're just starting to publish more about that. Ultimately, super, super, super top of mind for both LayerZero and Stargate side. And I think across the industry, especially if you ask kind of like the leading auditing firms, I think we're really seen as like far out on the forefront of that.
So thank you for your detailed answers. And then next question is, in order to operate Stargate properly, so the liquidity of a vault would be very important. So how does Stargate attract each chain's liquidity?
Yeah, it's a great question. So this was one of the fundamental things about Stargate. The focus of Stargate always was protocol-owned liquidity, because we had originally thought it was really dumb. You launch a new DEX, and it's great. You give away a bunch of emissions, and the TVL gets really high, and then you run out of emissions, and then hopefully the DEX generates enough volume to like keep the TVL. But if it doesn't, all the TVL leaves, and the whole project is just dead, right? That seemed like a really silly model and kind of a crazy bet to be making all the time on like the system of the protocol. So the focus of Stargate was always accrue enough protocol-owned liquidity that you don't need to rent liquidity anymore. So part of this, the initial auction and bonding curve that Stargate did, Stargate has about $100 to $150 million of protocol-owned liquidity that the protocol itself owns. It seeds in the pools, it attracts the LP's fees, it does all of this. And then on top of that, so the goal for, right, Stargate had like $4.4 billion in TVL early, but one thing everybody realized is you only functionally need like 350 million. So all the excess was just totally wasted, right? It was just giving away emissions and not using that liquidity at all. So emissions got wound down to where the TVL now is, I think it's like 400 to 500 million, which is right about where it wants to be. And so on anything on top of the protocol and liquidity, it needs to rent. So it gives out emissions for that. And the goal is almost all of the fees that Stargate attracts goes back to the protocol and builds in protocol and liquidity. All of the integrations that drive volume, all of these things go to Stargate's protocol and liquidity. And so the more POL it owns, the less it will need to give to emissions. So if Stargate gets to 350 million to 500 million of protocol and liquidity, it will not need to pay a single dollar in rented liquidity. It will no longer have emissions, and 100% of the fees will be aggregated within the protocol.
Okay, thank you, Bryan. So I think we have one more question from the audience. So next question is, are you planning on building another protocol based on the LayerZero rather than Stargate?
Yeah. So our general stance has been, like Stargate, we needed Stargate because you launch a messaging layer, awesome. Anybody can build anything, but functionally, it's going to take 6 months until somebody comes and invents these primitives that live on top. And so even something super simple like a yield aggregator, right? Like when you're in one setting, like all you want to do is unstake some money here and like stake it there. But when you go across chains, now you like unstake 10,000 here, and you want to stake 10,000 here, but like you don't have inventory anymore. You have it on chain A, you don't have it on chain B. Same thing with DEXs, same thing with all of these use cases, anything who deals in liquidity. And so Stargate's goal was totally abstract that away. So now the developers don't need to think about it, the users don't need to think about it, right? Now you can build this yield aggregator that's like unstake here. What happens in the background is unstake, add to Stargate, subtract from Stargate, and stake. And the user just clicks once, whole flow gets executed, like magic, they're just like farming in the other farm over there, right? SushiSwap's integration was 30 lines of code because Stargate could abstract away that portion. So all of those things, like we needed Stargate, one, to show what could be built, but also to give really high leverage to the apps building on top. We don't want, nor do we have time or bandwidth to build every application on top of LayerZero. So the goal is for everybody else to build the stuff that's interesting. There's about 8,000 contracts on testnet right now, so a huge amount of development activity happening of people building, which is amazing. It's like 1,500 on mainnet and about 8,000 on testnet, which is really crazy. Like I don't know the current number, but last check, I think Solana had like 1,000 active contracts or something. So like 8,000 is like an astronomical amount for dev activity. Solana is like active contracts. It was a little bit of a different metric. But what we will do is we will build tooling or protocols or whatever it takes to enable people to build more easily on LayerZero. So one of the big things we noticed was every application building on top struggled with predicting block time on the other side. So like you have some transaction and the user just like, it's a black box. They don't know, is it pending? Did it land? How do you tie these things together? So we just released LayerZero scan. So now you can track transactions across chain. There's an API. Now any developer building can say, transaction left here, can show the user it's in flight. Here's the exact expected time transaction landed, right? So now they have all of this status to do. But there's all of these other things on top of LayerZero that would be very interesting and again, open up developers. And so our general stance is we want other people to build it. If nobody else is going to build it and it's helpful to the ecosystem, we will build it if we can. So again, and always, they go, hopefully everybody else just builds it. We don't have the bandwidth to keep building these things, but we're building out tooling as much as we possibly can.
All right, so thank you for your explanation. And then, so we do not have any more questions. So I think it's time's up. So yeah, it's time to finish today's session. So Bryan, thank you for your today's time. And then I think that it was very valuable time for everybody here, including myself. So thanks again. Yep.
Thank you so much for having me.
Yeah. So. And then also, I'm from Lambda256. So is there any person who is interested in Lambda256? Just drop by the booth outside. Yep. Thank you.
Thank you very much for the great and intriguing discussion. Please give them another big round of applause. Thank you very much.